Hello, PreAlgebra. Welcome to another week. So far this year, we have focused on simplifying, combining like terms. We've been focused on working on expressions without an equal sign. Well, now we're going to be looking at an equal sign, and we're going to be starting with one-step equations. The whole goal when you have an equal sign is to get x by itself. You're trying to identify what values of the variable make it a true statement. And so when we solve, we want to undo what's there in order to get x by itself. Now, here's an example to start with. We have x plus 5 is equal to 16. Now, through check and guess, we can probably get the fact that x is 11. That is not as important as knowing how we can solve this, though, because then we can apply that same steps and same processes of solving to more complicated problems where we couldn't guess and check the answer. And so here, x plus 5 is equal to 16. If we want to get x by itself, if we want to figure out what value of x is going to make this true, then we want to undo plus 5. And that's where knowing our operations comes in. What undoes addition is subtraction. So we want to subtract by 5 on both sides of the equal sign, which gives us x is equal to 11. And that's how we can confirm that x is indeed actually 11. Now, what I just wrote there, x plus 5 is equal to 16, is the exact same thing as 5 plus x equal to 16. The reason why is because addition can happen in either way. We call that commutative. X plus 5 is the same thing as 5 plus x. And so it requires the exact same steps. Subtract by 5 on both sides of the equal sign. Notice I am not writing it underneath the x. The reason is because we want to combine our like terms and we want to focus on undoing the 5. So the 5 has to go to the other side of the equal sign where the 16 is. And so the 5s would cancel out, getting a 0. X is equal to 11, just like before. So let's take a look at another example here, this time with another operation. In this example, we have y minus 3 is equal to 20. So here it's going to be the exact same process. The only difference is identifying our operation. If we have y minus 3, what undoes subtraction is addition. So we want to add by 3 on both sides of the equation, on both sides of the equal sign. And so our y is then going to equal 23. So how is that happening? With the 5 up above and now with the 3, what ends up happening when we add by 3 is we have minus 3 plus 3 equal to 0. And then anything plus 0 is itself. So that's why canceling out works. That's why addition and subtraction undo each other. It's because it makes it 0. Negative 3 plus 3 is 0. Y plus 0 is just y. And so we can say that y is equal to 23. Now, as we wrote it, is the exact same thing as saying negative 3 plus y is equal to 20. We're still going to be adding by 3 on both sides, and our y will still equal 23. So either direction, either order works. As long as the negative is on the 3, that counts as subtraction, so we can add in order to solve for y. Now, let's take a look at another example here. In this example, I wanted to include a couple of negatives that would require us to simplify just a little bit first. So q minus negative 6 is equal to negative 7. Even though there are a lot of negatives here, don't fear, we're able to work through it and make it happen. First things first, let's simplify the negatives with the 6 and the q. And so when we have negative 6, the negatives are next to each other, so we're taking the opposite of negative 6. and the opposite of a negative is a positive. So we have q plus 6 is equal to negative 7. And now we have a problem just like we were working on before. Our goal is to get q by itself. What undoes addition is subtraction, so we want to subtract by 6 on both sides. Our value of q is equal to negative 7 minus 6, which is negative 13. So, ladies and gentlemen, why don't two negatives make a positive between the 7 and the 6? It's because the negatives aren't happening to each other. It is not negative 7. It is not negative 6. We're not subtracting by a negative anymore. Instead, we have a negative number, and then we're losing that many more. And so the answer is just further negative as a result. So, ladies and gentlemen, let's go ahead and take a look at the next example here. Ladies and gentlemen, the next example here is not looking at addition or subtraction. Now we're looking at multiplication. And so we really want to know, how do we solve with multiplication? And how we solve with multiplication requires us to understand the operations. What undoes multiplication is division. And so in this example, when I write 4x is equal to 20, first we have to understand that we're multiplying between 4 and x. Even though there's no symbol there, that's how we represent multiplication. And then to get x by itself, what undoes the multiplication is division. So we want to divide by 4 on both sides. Now when 4's cancel out here, we don't get 0, we get 1. And that's because we want 1x left over as a result. 1x is all we want. So we want to cancel out multiplication and division to get 1 and not 0. Because we still want an x there, but we want only 1x there, rather than 4 x's like the problem started with. And so our 1x is equal to 20 divided by 4, which is 5. Another example here. We have 18 is equal to negative 9n. First, same thing, multiplying between 9 and n. So that multiplication tells us, in order to solve for n, we have to divide. And in this case, we're dividing by negative 9. So you divide by negative 9 on both sides. Negative 9 divided by itself is 1, so we have our 1n left over. And ladies and gentlemen, a positive divided by a negative is a negative. So we have a negative number, and that number is 18 divided by 9. 18 divided by 9 is 2. So our n is negative 2. Ladies and gentlemen, the last example we're going to work through today is negative 14 equal to negative 2p. And so here's another example where two negatives happen to one another. First, just like before, we're dividing by negative 2 on both sides. The division comes because we're multiplying. So we choose to divide by negative 2 to undo the multiplication by negative 2 to p. So we end up with 1p left. So now we have negative 14 divided by negative 2. A negative divided by a negative is a positive. We're doing our opposites here. And so the reason why we're doing our opposites is because multiplication and division represent repetition. Addition is just including that many more. But multiplying is repeatedly doing that. And so that's why our negatives interact the way they do. That means we're taking the opposites. And so negative 14 divided by negative 2, a negative divided by a negative is a positive, and 14 divided by 2 is 7. And so p is equal to positive 7. Ladies and gentlemen, I hope that gives you the help you're looking for. If not, email me. I'm more than glad to help. And of course, I'll be seeing you guys later this week on Wednesday. Take care, and I'm looking forward to seeing you soon.